All right, we're live. Thanks everybody for coming to another Bitovi front-end training. This week we're going to be going through BitBalls. It is a charity basketball tournament application that I wrote to help host Bitovi's, or to help manage Bitovi's basketball tournament, which is actually going on this week, although teams are full. So if you want to play, look out for an email next year. So I'm just going to be going through how that works, and we're going to be paying a special attention to the service layer and how sessions work, and a little bit about how server-side rendering works with it. So let me share my screen and get started. And please, all the Bitovi people who are here, if you have any questions at any time, just ask. And please let me know if my video isn't sharing or something like that. I guess send me a message on Slack because I will not see it on my computer. Cool. So, as I said, we're going to be talking about BitBalls. It looks like this. It allows us to track stats and things like that for when people score. I think it's got about everything, pretty much everything that, everything that kind of goes into almost every single app that we've ever built. This has a piece of it. It really has a lot of the core problems that need to be solved for almost any JavaScript application. So as I said, I'm going to be going through its functionality, going to outline the technology that's used in it, going to talk about the different layers and where everything is in this application, including how the data model layer looks like, the services that are built on top of it, the components and models that connect to it, and the folder structure of where everything is. I'm going to be going through and I'm going to be paying special attention to how data relationships are handled, how sessions are handled and access rights, and then talk about server-side rendering. So this is the application. You can see it at bitballs.heroku app. You can see a list of players. And then you can see a list of tournaments. And this is a non-logged in user, can click a game. And then for a game, they can see a list of stats. And it can kind of show you where in the game you are, and you can click on a stat. There's Juan running out of frame right. Oh, actually, sorry, Juan. If your Juan is watching this, gotta get back on D, buddy. You can log in. Like an admin can log in, and then I actually registered for an account. Sorry, I was registering for an account. It sends you an email address, and then once your email is verified, someone else who's already an admin can see that your email has been verified, and then mark you as an admin. And then once you're an admin, you have the ability to basically create, update, and destroy all data. So here you can see now it looks a little bit different. I can create new games by picking a home team and away team for the game, which round it is, put a YouTube video. I can also create teams. And then within a game, I can edit stats. So this is actually Brian's brother. I could add a stat for, a one-pointer or something that he made. Users can, there's a users page, like I mentioned, that shows kind of who the users are and allows you to do some basic marking people as admin or not, and that's the functionality. And you can change your password and stuff like that. So let's talk about how the application's architecture, what are all the moving pieces of technology in this application. And in some ways, the first decision is in some ways affects a lot of other things, and that is your choice of data storage. And in this application, I chose Postgres, mostly because I was most familiar with it, with a SQL file database. So we're using Postgres. Our services layer is in Node, and Node I'm using DB Migrate to change. Migrations are a great tool for anybody at Bitovi who's, I mean, I know David, maybe if you're watching this, we can talk about it later because he mentioned that Facebook doesn't use migrations. I brought this up at the Node talk and everybody was shocked and nobody had actually read that article too. Migrations are a tool that allow you to change your database structure as the code evolves. I think they're just an essential tool in building backends when I've ever built them. I don't know how Facebook could manage without that, but they're super useful, and I'm using DB Migrate, which is a tool in Node.js. For handling incoming service requests, HTTP requests, I'm using Express, and then I'm having Express talk to Bookshelf for database. So Bookshelf is a ORM, an object relational mapper, and that is used to make SQL much more easily. I chose it because I'm familiar with Active Record, which is the Ruby on Rails version of this. These kind of tools, as we'll see later, are just, they make expressive services much more easy to wire up, and we're going to see all about that in a little bit. But Bookshelf is the ORM. Basically, just think of it as an easy way of making SQL. Express, so for logging in and handling authentication, I'm using Passport. This is Express middleware that makes it easy to connect to, like, have authentication via Twitter, Google, there's like 100 different authentication strategies. In this application, it's just using email password, which is the most simple one, but I still set it up so that if I wanted to add a lot of people log in through Gmail or Twitter or whatever, I could add that to this application relatively easily. And then finally, DoneSSR handles the server-side rendering parts of the application. So Express is kind of mediating between all of these different parts. If I had to write this application again, I would definitely be using Feathers because it's awesome. But I wrote that before I was really familiar or had looked into Feathers. So Steel.js is the module loader that's going to be used both on the client and the server. It's using the server for DoneSSR, but it's also using my client. That's why I have it down here like that. It's just a module loader. And then for the client side, it's a DoneJS application. DoneJS really means mostly Steel.js and CanJS. CanJS is really the parts the client is written with. CanJS mostly works by when you change the URL, that is translated into properties on CanRoute. Those properties in CanRoute are used to determine which kind of custom element should be shown for which page. So it's kind of a mapping from your route to which custom elements that represent a page should be shown. Those custom elements are built with CanComponent. Components all have a kind of a view model that handles the UI logic and things like that. So each custom element has a view model. That's where business logic is and UI logic. And it also has a view, that's CanStash, which is a templating engine. So components are kind of composed of those two things, and they work to build the interface on the page. And all of this uses jQuery underneath. And then finally, the application uses CanConnect, which is really the model layer. CanConnect to connect to the services that are exposed by Express. So that's the front-end technology. All of the back-end is hosted on Heroku. As I forgot the specific name is, it's not SaaS, it's Platform as a Service, I think is what Heroku is. PaaS.
Yeah.
Thank you. So the front end is all hosted on Firebase, and it's CDN. And I know Alexis has told me to use some other word besides CDN, but I always forget what it is. But that is this is where we're hosting all our static scripts so that they can be delivered more quickly to clients. And then for testing, we're using our test assertion library is QUnit. We use Testy as a test runner, which is kind of like Karma. It runs all of our assertions that are written in QUnit and our tests that are written in QUnit. And then Travis is what we use as our continuous integration system that detects whenever we push something to GitHub and will automatically run all of the tests in GitHub. It also, Travis, is set up to do continuous deployment, so when the application is merged in the master, it'll actually push everything out to Heroku in the Firebase. And finally, all of the application's documentation is written in document.js. So let's talk about the data model and service layer. Let's explore those. Is there any questions before I continue, though? This will make sense. I think this should make a lot of sense to most people with Bitovi. All right, continuing on. Let's talk about the data model. So this is really, a lot of times when I come to an application, this is the first thing that I will sketch out. I'll do it in Draw.io, or I'll just do it in Photoshop, or I'll do it in Pencil. The first thing I figure out is the data layer and how it relates. And I try to get as close to good naming and good conventions as I possibly can before starting. So, I know that I've got tournaments, and each one of those has a date. I've got players with a name, age, and height. I've got a team, and a team can have a name and a color, and it belongs to a tournament, and it belongs to a bunch of players. I could have made a has and belongs to many relationship here, which would have made the application a little bit harder, but also just not necessary because there's only 4 players on a team. I don't really see that changing, so there was no reason to make that. So I'll draw the relationships. A game has a court and a round, and it belongs to a tournament, and also belongs to a home ID and away team. So draw those relationships. So games have teams, teams belong to games. And that terminology that I use comes from my experience with Ruby on Rails. There's has and belongs to many relationships. There's belongs to relationships. Has many relationships, and there's kind of like has one relationships. But for the most part, we're just dealing with like a team belongs to a player 1, belongs to a player 2, belongs to a player 3. That's kind of how we say this relationship. A player has many teams that they've been on. So there's stats. Stat is for a game and for a player. Right, and they'll have like a time the stat happened, a value for the stat, and a type of stat, like 1-pointer, 2-pointer, that kind of thing. Finally, not connected to any of this data currently is the user management and session. So a user is kind of an entity in the database with an email, password, and whether they're verified. There's a little bit extra information that I'm not including here. And there's also a session, and a session is a data type that's not in this database. It's kind of in memory in Passport, but it's still a logical entity. And I find that a lot of times people mash up user and session into kind of one gross entity together. We'll talk about more why you shouldn't do that later, but session is a different entity than user. But session has a user, right? So once I've figured these, this data structure out, well, the next thing is I make the service layer, and the service layer should be as uniform as possible and relate directly to the data layer. I think it's important for when we're working on our clients to try to. A lot of times, our clients on the backend teams will try to do stuff that's a little too smart. Like they'll try to mash up services, and we'll talk about this more throughout this presentation. But they'll try to have.
Justin, sorry to interrupt you, but they're saying that they're unable to see your screen on the watching link.
Oh, really?
That's what they said.
On the YouTube link?
Yeah, I think that's what. Yeah, yes, on the YouTube link. I mean, I'll go there and see it myself.
Okay. Let's see your screen on the watcher. Is it like from all time, Ilya?
That's what it is. Yeah, I see myself now. Maybe share your screen again? Yeah, share your screen again.
Okay, I'll share my screen again. the whole time. Okay, shared.
I was just talking to you, talking to me on YouTube. That really just happened.
Okay, so hopefully they can see it now. I don't know if there's like a delay, or just for a couple minutes. Ugh. Why don't? Okay, annoying. Anyways,
Yeah, just continue.
I'm just going to continue. So if people didn't see it, the data layer that I was talking about was this, right? Tournaments, players, stats, teams, and games.
We're good now.
Okay, cool. So what I try to do is create a service layer that directly parallels the data layer. I think, like I was saying, sometimes our clients try to do things and be smart. They'll say like, oh, you know, we don't really need a game service because we don't really need players because when we load a game, we're always just going to get players. So we won't create that. I'll talk about it a lot through this presentation, but I think that's, in short, it's short-sighted. You never know how your application is going to evolve. I try to create as powerful and flexible service layers as possible that directly mimic the data layer. Try to make the service layer as dumb and as flexible as possible. So for every data type, there's a service. And the only one that's a little bit odd is going to be session, because it's not sessions. This is because it's kind of a singleton, but everything else has got a plural name. And that's kind of how I like it. So that I expect if you go to services tournaments, you're getting a list of tournaments. The name services versus API, I don't really care here, but I do like these names to be uniform to what their data type is. So what I like and works very well with CanConnect and CanJS in general is when I go to services/teams, it's going to respond back with the basically raw data, the raw record data from that table in the database, right? So if services teams have ID, color, name, and all these player IDs and a tournament that they belong to, that is exactly what should be sent back by default for services teams. No more and no less, just everything. Now, if there's security concerns, of course, those trump this, but when you're starting, this is what I think the service layer should look like, which is very uniform. The next thing, and we'll see how I do it, is we make it so that the service layer can support filtering. So if I wanted to get only the teams where the tournament ID is 7, I can do this, and I can actually do a where with any property in this, any field in this or column in this table. So I could filter where color is red or whatever I wanted. Now, the really interesting thing I think that I like to set up is these expressive services that handle relationships and joins and things like that. So here, I'm creating, I want to be able to say, I want teams, but I want to bring in the related players. So with the service layer, I want to be able to do is see that, hey, these with relateds are coming in, and instead of just providing player 1 ID is 15, we're also going to do a join and get player 1 and include all of its data. I also want to be able to get, so not only do I want to be able to get lists, I want to be able to get single entities. These should support similar like joins and things like that. But again, just by default, just the raw data from the record in the database. I want to be able to create data. For creating data, I'm going to use post to teams. I use, again, just raw data in the database. And it will come back with whatever the data that I posted, basically what the record looks like after I posted. So it'll include the ID. If I want to update, I just paste in, I should just send the full content of what the record should look like. Yes, it's nice if we support patch, but I just think put is the easier one to support in the beginning. plus Can Connect doesn't support it very well. So that's another good reason. And just it's easier. So here I'm just putting the full record, and I expect the full record back. Delete, just need to hit the endpoint, and just needs to respond with a successful response. Doesn't even need to be an object. So I do that same pattern that I just did for Teams. I do that everywhere, right? So that I can CRUD every single type in the same way. Okay, so let's look at the components now. Just the next thing I do is once I've kind of figured out my data layer and my service layer, I tend to document a little bit of my service layer. Then I'll start figuring out which components do what. So I'll say, okay, I have a navigation component, and that's going to manage the, showing what page we're on and this little login or register link. I'm going to have a tournament list that deals with this tournament list and create a new tournament. I'm going to have a player list that uses a sub player edit component. And these are the module names, if it's not clear. They're not the actual component names, they're the module names. I'm going to have a player list that uses a player edit to either create a player or edit a player, so it can kind of like have multiples of these on the page at once. I have a tournament details that helps build, the teams and games for a tournament, and I have a game details that for the game. You'll notice one thing that I do is I like, and not everybody does this at Bitovi, but this is one thing that I do, is I like having noun, like verb or action, as my folder structure. So we'll see this in a little bit. But some people like dashes and other things. This is I really don't care. Everybody can do it whatever way they want to. This is just my personal preference because I like to line up my thinking with these kind of CRUD, CRUD terms, which I recognize is not really natural in a larger application. When I control the design of this, I lined it up with CRUD very well on purpose. That's not necessarily something that's going to be true in every application. So then I have a user details and a user list. User details allows you to register or update a user's password. User list allows you to do just lists all the users and make them an admin. So those are the parts of the app. The components. Now let's see the folder structure, how I organized BitBalls. So hopefully kicking off into video isn't what's wrecking my stream. Please let me know if it is, because then we're just gonna have problems. So in BitBalls, everything is in this. So there's kind of divided in two parts. There's the services code, and then there's the client code. The client code is all in this public folder, and the services code is everywhere else. It's all in these models, migrations, and everything that's kind of below here. So services theme, all of this stuff is services code. Everything in the client is inside this public. So the main part, the application, the service application part of the application, the Node app, starts at, of course, package.json. This has scripts that do a whole bunch of things that I'm not going to really get into, list all of its dependencies, your standard package.json. I've really become a big fan of using package.json scripts over something like Grunt or Gulp lately, just because, I don't know, it does 90% of the job that you really need most of the time. Okay, so the migrations are all in this migrations folder. These are used to, like I said, migrate the app from one point to another. A migration looks like this. This is the first migration. It creates the players table with these columns.
Are these generated?
It's not generated. There is a generator, but it just generates like an empty skeleton. You have to fill out this stuff. Um,
What's generating that skeleton?
DB migrate. There's like DB migrate command that creates like a generator with the timestamp, and you can like I forgot how you write it, but it's like DB migrate, like I don't know, create or something, or create
Is that
migration.
is it a node plugin?
Yeah, DB migrate is a NodeJS package.
Gotcha.
But there are since having written this, especially because Bookshelf is the ORM there, and uses something called Nex, KNEX. There is a Nex-based migration library that I've heard is better than DB migrate. I haven't used it, but that's what I've heard. So if I were to write this again, I would probably check that out. And that way I didn't have to have kind of two different systems. My configuration for DB migrate, I wouldn't have to have two. I kind of have a configuration for DB migrate and I have a very similar configuration for Bookshelf. I would only have to have one configuration for if I was using the Nex version of migrations. Anyway, so that's where my migrations are. So let's check out the server-side models. So I use Bookshelf to make models for the back end. This is my ORM. You can see here I'm extending. You can see I like this also because of how similar it is to what CanJS looks like, and but here I can say, hey, stats has many. Oh, sorry. A game has many stats through the game ID property on a stat. So the stat table has a game ID. Games have a bunch of stats. So I can say, give me a game, and then I can say, give me all of its stats. And this decoration is what does that. And we'll use this for allowing joins and with related momentarily. So those are all of our models. Check out the services. So here's what the services look like. This is the services layer for games. I'm just using, I'm just essentially, I'm essentially using Express to listen to the CRUD parts, like delete, post, put. Get was towards the beginning. Where did that go? Oh, hold on. Google Hangouts just freaked out. Can you see my screen still?
Yes.
Yes. Yeah.
I'm sure no one else can. I'm worried the other people can't, so I'm gonna do a preemptive strike and reshare my screen. Hey. All right, let's share it again.
That code looks generic enough that you could probably abstract it out further if you wanted to. Like it's
absolutely. Or I think that I would imagine, and I don't know if David's around right now or Marshall. Definitely not. Marshall hopefully isn't around because he just had a kid. I think that. Hold on a second. Pause it. Okay. Hold on. Give me back to my services, please. There you go. Yeah, I think that probably Feathers might be able to do that for you. There's a way that you can just provide, I think, an ORM or some kind of connection, something like that to Feathers, and it just does that. Anyways, the big thing I wanted to show here is that I'm just listening for. I'm using Express to listen for a URL, and then I'm using my ORM to get the data for it. So I'm using my game from my game model, and just using whatever, and we'll see just whatever was passed in to the service layer. I'm just passing that as the query to the game model, and then whatever games it gives me back, that's what I'm sending out. And yeah, every service layer, with the exception of user and session, looks exactly like this. So there's a little bit of admin checking going on for the delete, put, and post, but it's very simple. Just use the ORM. No no database SQL required. And then finally, I have a index.js. This is the main entry point. So if you start the application by running like node index.js, this is what gets kicked off. This requires all of those services. Also does some stuff to like, host static files, set up live reload and development mode. It kicks off everything. So let's check out the public, where the static files are. This again has its own package.json. This is for all of the client dependencies. So this has all of the can.js and steel, that kind of stuff. It has the main entry point, which is the index.stash, which is typical of a DoneJS application. Index.stash here is what kicks everything off, like loads kind of the initial modules, the navigation component, things like that you can see us using. And then finally, there's this page component, and that's really what determines, given the state of can route, what should be rendered. And then the app.js is kind of the view model, and I have this, the routing rules are set up here, which everybody's seen before. You can see that page component. Hold on, I need to rewind a little bit here. You can see this page component. This is a helper that, like, I'll go into it a little bit later. I think we need a nicer way of kind of setting up basic navigation routing, but I basically have a page component config property in my view model that is an object, kind of a live, it's a getter that looks at the properties on can route and then sets itself up with a module name, component name, and then this just makes it so that it's going to import that module, and then when it's resolved, it's going to render that component on the page. It's not great, and then this is that function, right? It's just checking if the page is. It checks what the page is. If the page, well, in this case, it's not just checking. It's saying if there's a game ID, that means that we're on the game details component page. So load this module, and then here's going to be all the attributes that you want written into the page. It's just a conventional function that, checks the app state basically and figures out which component should be rendered. It's not pretty, but it sure works. I do think we should eventually find something that's prettier. The one thing I do like about it, though, is allows 404s and things like that. So here I'm saying that, hey, if there's no, and this is a good thing for everybody to learn if you're doing SSR with DoneJS, if a page doesn't exist and you want to, put a 404 page up and server-side render that, here I'm saying the title of the page is page not found. The component I want to add to the page is the 404 component. Its module I want to load is 404.component file, and the status code I actually want to send back, server-side rendering to send back, is 404. And that will actually send a 404 response. Done's SSR will send that back. So this works. It's just not beautiful. Our routing has never been beautiful. It's always been very, very functional. Okay, so the components folder. Here, like we've kind of already seen what the components are. I've just organized them here. Everything is a modlet. So game details again has its own test page, its own demo page. Own everything. Here's the demo page for the game details page. Some rooster teeth lion thing. And then it has its own tests, of course. Let's look at the models real quick. I have all the models flat. Sometimes people put these in folders. I tend not to. And I'm defining my game and game type, and I'm connecting it to the services games URL. So that's my models and the components and where everything is. Okay. So now let's talk about where I think things get interesting is how this application handles data relationships. And a big problem is the perceived conflict between performance and maintainability. And I think that there's a way, I think people get too hung up on making things perform super well, especially like back-end teams, where they should be much more focused on maintainability. But I think that the approach that I use strikes a really good balance, especially makes it very maintainable, makes the application perform like reasonably well until you get to scaling problems that anybody would have to deal with. So I think there's a good approach. So let me explain my approach. So starting with a page like this, your average, if you were just to use the RESTful services that I described in the beginning without their ability to do joins, you would have to make a lot of requests, right? You'd have to get the game, and then you could start getting the stats for the game. Where game ID equals 9, give me all those stats. So you can make 2 parallel requests. But the problem is to fill out the game, the team names and all of the players, well, then you have to make 2 more requests for each team. And then to get the players, you'd have to make 8 more requests. Now making 12 requests isn't great, but what's even worse is that you have this waterfall. You have to do these 3 batches in serial to get everything, because you have to wait before you get the players. You have to wait for the teams, and before you get the teams, you have to wait for the games. So what a lot of times back-end developers will do is they'll just cut right to the chase and say, hey, well, if you go to services games, well, we're just gonna tack on all of the related information for you just right away. I don't like this, because what if you had another page that just wanted the stats for a game and just wanted to list how many 2-pointers there were for a game or something? You don't know what your application is going to look like, so tacking on all of this information just is unnecessary. That's where expressive services come in. What I want to be able to do is have the client control what joins should be happening, so that the client can kind of be optimal and treat the service side as able to do its own kind of optimizations. So here I could say I want to get the game for whatever the game ID is, and I want to bring in its stats, and I want to bring in its home team and away team and all of their players. So I want to be able in the client to write something like this and make a service layer that's smart enough to handle it. So that would hopefully get translated to a request like is on the right here. So we just go to services/games, add all these with related. If people aren't familiar, don't know this already, if you just use jQuery to make a request, and this is your data that's kind of on the left here, this game.get, jQuery will automatically serialize it to this with related bracket thing on the right. You can actually serialize nested objects, nested arrays, and to what is a kind of URL-friendly, I don't know what you want to call it, query string. That will kind of get reverse, hydrated into a normal JavaScript object by Express. Sounds like someone wants to say something.
Well, I was going to ask, does it have the ability to do the select part as well? To say give me these fields, but not others?
No, the system that I built does not have the ability to do that. I think that's that's a optimization I would tend to add on much later. I would not, I think it's, unless you have some type of property. I mean, sometimes you can have some file that's kilobytes, some image or something that might be kilobytes big, then you might add that as an additional available operator or whatever you want to call it parameter that's available to say I don't include these or only include these properties, but that's not something I built for this. Because in my experience, those things are not, they're always in like one project, or every project has one or two of those where you don't really want to include it, but it's not so ubiquitous that it's like every single service layer needs that. Okay, so anyways, and then the server would see this kind of with related query string and then do the right thing, do the join, include the other additional data. So that's all done because we're using this ORM. Because we made this game ORM and we decorated how there's a home team, a game has a home team and away team, this ORM knows how to actually be able to see with related and set up the join correctly. Similarly, teams have, for their player 1, 2, and 3 property, they're similarly decorated to be able to go load that player. So on our service layer, which we looked at briefly, all I need to do to make that with related work is basically just take in the query and just pass it to the ORM. So if I'm getting a single entity, for some reason the ORM is a little weird, I have to call .fetch. So if I'm getting a single game, I pass the query to fetch, and it just does the right thing, sets up all the joins. And if I am requesting lots of games, I do query and I pass in the query to the query, and I don't pass it into fetch. I don't know why. I think it's a bug on their behalf. I think I should just be able to pass in either to fetch on both or query to both. But this is how it worked. Maybe they fixed it since. But that's all you have to set up, and all of that with related, all of that filtering by where just works. So we can just see like other examples how this was used. The first one is the example we've already seen. Give me a game, all of its stats, all of its home team, away team, and their players. Right? This operator where I can write home team dot player 1, and I could even keep going deeper. If player 1 had things, I could do dot address or something like that. I don't know. So then I can use it if I wanted just a game and its stats. That's the second example. And finally, this also supports sorting and limit and offset. So if I wanted if I wanted all games for tournament 5 where the home team was green, so give me all games for the home team being the green team in this tournament, and I could say bring in its stats in the home team, bring all the stats and also bring in the home team information, and then sort by round, so which round the game happened in, and then I only want, I guess, round, because my offset is 2, give me 2 items after the third, or starting with the third game, right? And all of this works with just this service layer. You have all this power, freedom, and flexibility with, like, I don't know, 13 lines of code. That's, to me, is awesome, right? Our job should be trying to make it so the backend teams don't have to do a lot of work, and I think this is a good way of making them, spend time with their family. And then they can focus on actually getting it right, and then we can go home and hang out with our families because the service layer works when we're actually releasing the application, when we start dropping fixtures. So let's talk about how the service, how users, sessions, and accounts, and that kind of thing works. So to create a user, just as a reminder, this is what that looks like. You can click this register. You can type in a username and password and hit create, and that sends you that email which someone can verify. Now, these slides have been edited a little bit, the code, just to remove some extra stuff that would have just distracted. So if you look in actual, user details.stash, it's going to look a little bit different, but I'm mostly just rearranged it to highlight the important parts. So everybody should be pretty familiar with how this all works here on the client side. I've got a form with an input value that's connected to, where's my mouse? Oh, I can't show it. That's kind of lame. I've got an input that's connected to the user email. I've got another input that's connected to the user password. And then I have a submit button that will call save user when the form is submitted. Why can't my mouse show up? Can anybody else see my mouse? I can't see it. This is lame.
No.
I want my mouse. I really want my mouse.
Well, no.
Oh well, I forgot. I forgot. I changed the
There's a
slides.
tiny mouse.
That's okay. I forgot. I changed the slides to highlight these things anyways when I gave this import link. So never mind. It's okay. I don't need my mouse. So I've got these forms. I've got the button. You click submit, and that calls save user. The view model for the details, the user details view model, is a can map, and it has a user property that's like, it has kind of an empty user property that's just hanging out. So whenever there's an instance of this view model is created, it's just a user property just like sitting there waiting to be, I don't know, have properties set on it. When save user is called, I'm going to prevent the default behavior because I don't want the form to actually submit, and then I'm going to save that user because it already has the username and password put on it, hopefully. Here you could add a little bit of validation or whatever, but I'm not doing that in this application. And then if the save is successful, I'm going to...
Hey, Justin, they lost your screen.
I wonder if it's when I lose my mouse, if that's when it's happening. Yeah, I can see my mouse now. Maybe that's like the canary in this coal mine. Okay, hopefully it's back for everybody. Okay, so anyways, I have the view model. It has this empty default user, and save user is just going to save the user, and then when it comes back, we're going to set the session on the we're going to actually update the view model session property, which will actually update the application view model session property with a new session for that user. So in some ways, like once we create a user, it's also going to automatically log that person in. And then I'm going to redirect them to the account page. But
Definitely do not see your screen now.
You don't see it either?
Even on the Hangout, see your face.
Oh my goodness. You guys, let me know as soon as you can. Don't be bashful.
Yes.
I feel so dumb talking to myself. Okay. Anyways, view model has this empty user property. When save user is called, it's going to actually save the user information. And you'll see here after that's done, it will actually create this new session object for that user, which will effectively log the person in the client. That's actually what's going to happen on the server side too. And then we're redirecting them to the account page. So the user save is what's actually going to call the user model save. So that's done here. So we create a user type. There's a can map. And then all we really do is we connect it to the services users with Supermap. So that's going to make a request. Oh, yeah, I forgot. Set algebra does a lot of cool stuff. This is me telling people to ask me about it at the end of this presentation. Okay, so that model, the client model, is going to hit our Express services. Our Express services, here we have ways to get the user, update a user, and delete a user. We'll see those in a moment. But what we're going to focus on is what it takes to create a user and like email them and all of that. And that's done in the Express service that handles posting to services users. And you can see it's using passport.useSignup up above, and that's kind of Passport's configuration that is for the simple email password authentication strategy. So let's break this down and see what's going on. First, before we even get to Passport, we want to do some verification and just make sure that the user sent a password. So we have this like little middleware here that just simply checks if there's not a password, throw up, otherwise go to Passport. So Passport authenticate signup. This is basically saying, hey Passport, give me the signup authentication strategy that you've configured, and that's going to return another middleware. Let's see what that signup configuration looks like. So here we're configuring the signup middleware strategy for Passport as a local strategy. You configure what the username field is. In this case, and it's going to be the email. Instead of really what we're configuring is the username password, but we're going to call it email password. So having done that, you have this other function that handles once kind of Passport has set itself up. You need to call done essentially once you have the created user. So I'm going to create. What I do here is I use the ORM to say, get me my model, get my user model. Basically I'm seeing if there's a user already created for the same email, and if there is, I'm going to complain and say that username already exists. And then I'm going to actually create the user. I'm going to create you should always hash your passwords. I'm also creating a verification hash, which will be part of the email that gets sent out. And then I'm going to create a user with the ORM in the database with all of that information, and then save them. And then if that user was saved successfully, I'm going to call back Passport's done method with the new user. And that will actually log that user into Passport's session system. So now, not only have we created a user, we've logged in a user. And now, once that's happened, we want to email the user. So we have this other middleware that's going to take that user. So once Passport, if someone's logged in Passport, it actually adds to the request object a user property for the logged in user. So now we have that because of Passport. We're just going to use that user to kind of construct a simple email, and then we're going to use NodeMail to email that user. If James is watching, thank you, James, for setting all of this up. And then finally, once we've emailed the user, we're going to send back just like we need to respond to a put request with the new the data for that record in the database. We're going to respond with that, but of course we're going to omit the sensitive data that should not be sent back, like their password hash, things like that. And I can send that to the client. So that's how you can create a new user through Passport. Now let's talk about how we can tell from the client if we're logged in or not. So the client in the application view model is always going to make a request every time a new app, like the application starts up. We have the session property here that's going to, whenever the new instance of app view model is created, it's always going to say, hey, get me the session. Oh, make an AJAX request. Tell me if there's a session or not. It's going to use the session client model to do that. And if there is a session, if it was successful, it's going to set its session property as that session. Now this always feels a little weird. Like you could think of it, if we didn't have server-side rendering, you could think of it as we're going to send out the whole client, we're going to send out the HTML, that's dummy HTML, and then the application is going to make a request right back to see if the person is logged in or not. Feels a little weird, but it works super good. And it works extra good when you've added, you don't have to worry about the performance problems of that once you've added server-side rendering, because with server-side rendering, the data that this is making an AJAX request for is part of the HTML response. So it's really not doing anything. There's no actual request being made on a server-side rendered page. So that's going to make hit our services session service. And all that's going to do, because Passport adds this request.user property, all that's going to do is return an object for the session, and then it's going to have its nested user data inside of it with the omitted sensitive properties. So a big thing you'll notice here, and if there is no session, it says no session. So a big thing to notice here is that my session data comes back like this. It comes back as an object. Yeah, there's an ID, which is the user's ID, but really it comes back as an object with a user nested inside of it. The reason is because a session is a distinct entity from a user. A session can have a created at, expires at properties maybe. Maybe there's other information that relates to the session, like when it's going to die or how long it's going to live for. That's distinct from the user that's logged in. So that's why, that's why I have this nested user property. A lot of times I see people stick these on the session request directly, but you should always nest inside this user. And if I'm being really, really careful, I could actually make this be a GET request and say with related user, and then only then would you actually see the user. That would be if I was super slick, but I'm not that slick. Okay, so how does it actually work to handle? How does that user kind of property really get configured to be there and to work? Passport, hold on. Passport, you configure these serialized user and deserialized user, and essentially the serialized user, given kind of the hydrated form of a user, like a user ORM object, model object. Well, what's unique about that? Well, it's just the ID, and then you also provide the reverse, which is to hydrate. This should be called hydrate user now. Given an ID, get the actual instance and call back done at that actual instance. And then there's just a little bit of like cookie setup stuff with Passport. But this is the real meat of it right here. So that this sets up Passport to look at an incoming cookie, it'll try to read that ID from it, and then kind of create the user. So how does authentication work? Really, authentication is I just have on a session, I have this little helper, is admin, is this session an admin helper, which all of that's going to do is check if there's a user, and if the user is an admin, it's going to return whatever is there, true or false. And then most of my application, it's just I'm passing that session is admin property to subcomponents, in this case tournament details. So I'm saying, hey, there's an is admin property on tournament details that's connected to whether the session is an admin, and I just use that to decide whether I should write out those forms where only the admin can like edit stuff. So only an admin should be able to create a new game, so I just protect it. Someone have a question? People can hear me?
Yeah. Yep.
Awesome. Cool. All right. So just quickly creating the session, what that looks like. Same kind of thing. I'm going to have an empty dummy session on Navigation.js's view model. And here I've just got a form that connects the to the email, the session user's email, and to the temporary placeholder session's password. And then when someone clicks create session, someone clicks the button to create a session, it's just going to call create session, and create session is going to do pretty much the same thing. It's going to call save on the session, and then it's going to update the application view model with that session property, with that new session that was just created, and it's going to replace its placeholder session that it just saved with a new placeholder session. So that if we logged out, then logged right back in, this placeholder session, there's kind of a new placeholder one to play with. And that's going to post data, again, that's nested. It's just going to post an object, and within that object is going to be the user property with the email and password. Service layer to handle logging someone in is going to get that user by their email, and if we have a user there, we're going to check and make sure the password is valid by rehashing their password and seeing if it matches the hashed password we have in the database. And if it does, Passport provides this login method where I can just call .login and pass it the user entity. And then once that's successful, it calls once Passport has logged itself in, then I can just call this. I just send back the data for the newly created user. So that's what this is just doing, or for the newly created session, which has that user inside of it, without any sensitive data. Destroying the session, there's a logout button. You click it, it calls logout on the view model. All that's going to do is call destroy on the session instance. And that's going to do a delete to the service layer, and that is handled super easy. There's a logout method that Passport provides. I just call the logout method and return with just empty JavaScript object. Any questions there about how sessions were handled? Hopefully pretty straightforward.
Yeah, seems pretty straightforward.
Cool.
Are you going to talk about how server-side rendered sessions are handled?
Very briefly, I'm about to. So let's talk about how server-side rendering works. I'm not really going to go through this because if you haven't seen this, there's a million videos where I talk about the performance benefits of server-side rendering and how DoneJS basically removes one serial request and can speed things up quite a bit. So one thing that we've talked about, and I'm just going to give a high-level explanation of this, is how server-side rendering works with AJAX requests, and then how that also works with AJAX requests that need to have like a cookie and sessions, and how server-side rendering can also handle sessions, which is kind of, I think, a really a real big differentiator for us in our server-side rendering, I think. I've got to imagine, considering what we had to do, and Matthew and James have a big part of it. But on a high level, how server-side rendering, let's start with how server-side rendering just normally handles an application without sessions. So if I'm requesting the players page, the node process is going to handle that, and what it's going to do is say it's going to start up a new virtual DOM, and it's going to kind of start up like a new context for rendering that application, a new zone, really. And in the lifetime of that, you can think of the lifetime of that page, there's going to be an AJAX request to go get players, to go to services/players, right? Our models, our client models are going to be making these requests. So that's going to make a request kind of out to another express services players, and zones are smart enough, we're kind of smart enough to hang up in some ways, hang up the event loop to allow, while this request is being made, to allow other page requests to come in. So now someone else wants the tournaments page, we can start building that DOM up while this request is being made for the DOM that is going to represent this player's page. So that when players returns, well, we'll finally kind of have the document updated, and then we can send that back to the client as a server-side response. And then we do the same thing with tournaments. Once that finally returns, we're going to kind of switch the context to which is the active document and update that with all the different tournaments and respond with that to the user. Now all of this gets a little bit trickier when you add sessions, because these requests also need to be made with the cookie that's kind of incoming from players and from tournaments. So that's what happens. So let's say players had, so when this players request, so someone kind of refreshed their page on players. Okay, so we get that, and it's going to have a cookie because the person had already logged in. What we do is we set up on the actual document, that kind of global document, that temporary global document, that document for that zone, we take whatever incoming cookie came in from Express and we set up that document accordingly. And we set it up so AJAX requests also coming out of here are going to include that same cookie, so that, you know, in the data services where Passport is running, it will see the right cookie and respond with the right in the right way, that the, you know, the person, you know, there's really nothing in this application that's really protected that is going to be server-side rendered, except for the session. And in that case, yeah, the session will come with a cookie and will respond, hey, you've actually logged in, here's your user, current user, and you put that in the top right. Instead of showing log in, we show log out. Same will have on players page. A different players page might not have a cookie, so that would respond a little bit differently. You know, this one will get the log in, the one without the cookie will get log out. So this was a lot of good work by, again, Matthew and James to like make this whole, you know, flow possible. So we all don't have to worry about it. You should just be able to make AJAX requests and everything should just work. The SSR parts in this application, because it's kind of one unified node service layer, looks like this. I put this actually in my public folder. I have a service.js that's going to require done SSR middleware and configure this SSR function to basically load the index.stash. You basically have to point to the main entry point of the application, and this returns a middleware that can be used by Express. Again, all of the stuff that I just talked about is at donejs.com/bitballshtml, where it's all worked through, and you can take it at your own pace. There's also a lot of good documentation for every part of the app, and I mean, we documented it super thoroughly, or like I think as thoroughly as any one of our applications has been documented. And you can run all of the tests. Everything is a demo page. It's a really great application to learn from. And that's it. Any questions? So my goal for this was, you know, hopefully people could watch this and have a feeling on how to bootstrap application development. Like if they wanted to just turn an app over, get logging in, and all of that kind of stuff all set up, they would have an idea of how to approach it. If you don't feel that way right now, then that's a perfect time to ask a question.
I think from my side it was all fairly clear. The stuff that I'd have to look over would be the SSR rendering flow, since I haven't used that yet. But yeah, it's good to hear that's in the guide, and I'll look through that.
Cool. Yeah, the SSR stuff for the most part is just you configure your middleware and then you just tell Express to use that middleware. And that's, you just have to put it in the right place, which tends to be like, I think, last for the most part.
Right.
Yeah.
So you're talking about how the way that you know, how you can make an AJAX request and it will turn that object into a query string, which gets passed to, you pass that, I think did you pass that directly into the ORM?
Mm-hmm.
Excuse me?
ORM.
So it knows, it uses the same data structure as well.
Yeah, so I purposely picked my service layer to match what the ORM wanted. So the
layer.
I designed my service layer. So my service layer, like the request the client makes, uses with related, offset limit, source, by, and where.
Those are all bookshelf terms.
And bookshelf, that's exactly what bookshelf is looking for to make its query. So it's not a coincidence that I'm using where, with, related, whatever. It's just I'm using what my ORM provides, and I totally recommend doing that. With Ruby on Rails, it's include or join. Make it include or join. Follow your ORM's conventions. And I think that's the most important part of this talk at BitBalls is really just that, like, how to set up a service layer where no matter how the client changes in the future, it's prepared to handle that, or as prepared as it could possibly be. You don't have to go back to the back-end person saying, oh, can you make these changes now? Because mostly the client can do what it wants.
Yeah, that's what I found interesting about it is you're kind of getting the same benefits that people get from what's it called, GraphQL, where the client can kind of make database requests on its own, but you're doing it in a RESTful way.
Yeah.
Cool.
Yeah, it's cool. The only other thing I would have people check out is right now with Can Connect, if you're using the latest, if you're using pre, we actually made a reference type that we made a reference type that handles NoSQL situations really well. So like SQL and NoSQL situations kind of need to be treated a little differently, and I think that this approach is really good for normalized RESTful databases. And for NoSQL, you need this references type that we just made that can handle kind of more document-like structures with relationships and different entities nested in the document. So look out for that soon, I guess. And thanks, Obaid, for making that.
Looking forward to that.
Awesome. Well, that's it, I guess. Thanks, everybody, for watching. Hopefully the video came through. I might have to re-record this into a more coherent presentation without those drops. But thank you.